Alright, so today we're going to talk about solving rational equations. So our steps here say to solve a rational equation, complete the following steps. List any domain restrictions, because remember these are the variable values that will cause the denominator to equal 0. Identify the least common multiple of the denominators. Multiply both sides of the equation by the least common multiple. Again, this allows us to clear the fractions. Solve the resulting equation, and then check your solutions in the original equation. If any of the solutions cause the denominators to equal 0, then we would discard them. So if you look at our example here, I've got x over 5 minus 5 over x equals 0. So if you look at the domain restrictions, we're looking at what value is going to make this to become 0, okay? So when we're looking at making this become 0, we're saying that x cannot equal 0. So again, because we don't want our denominator to be 0, that means x can't equal 0. So that is our one domain restriction. So now if I look at the two denominators, I need to come up with the least common multiple. Well, the least common multiple of the two denominators is 5x because it has both the factors of 5 and of x. So if I take my equation and I multiply the whole thing by 5x, and really this is like 5x over 1, I'm going to have 5x squared divided by 5 minus 25x divided by x equals 5x times 0. Now canceling out what's common, so let's see, we've got a 5 in the numerator and a 5 in the denominator, an x and an x, and then obviously 5x times 0 is just going to give us 0. I'm left with x squared minus 25 equals 0. If I subtract the 25, I get x squared equals 25, and then I take the square root, and as we remember from last unit, when we take the square root, we have to consider both the positive and the negative root. So we have both plus or minus the square root of 25, which means that x equals plus or minus 5. Now, because neither of these values is equal to 0, which was our initial domain restriction, and if we were to plug them in, we would still have the, it would satisfy the equation. So these are, in fact, our solutions. So let's look at another example. So our next example down here says solve for the given variable and remember to check your solutions using the original equation. So now what makes this one different in number 2 is that I got 3 over 6 minus x equals x minus 3 over x minus 6. And we can tell that our denominators look pretty similar, right? So these are both pretty similar looking. If I were to identify my domain restriction, we know that x cannot equal 6. Now, if you remember back, we had some problems in the last unit where we can factor a -1 out of here. And if I factor a -1 out of both terms, I've got -1 times -3 over -1 times x minus 6. Again, taking a -1 out of the positive 6 makes it a -6, and taking a -1 out of negative x makes it a positive x. And if I want to break this up, the only way to get a positive 3 was if I had -1 times -3. And so this is equal to still 3 minus, oops, let's erase that. 3 minus x, still over x minus 6. Our -1s will cancel, and I have -3 over x minus 6 equals 3 minus x over x minus 6. Again, this is a 6. Not a 3. And, man, I'm making all the mistakes. Sorry about that. There we go. Okay, so we can see that our two denominators are the same, which means our numerators have to be equal to each other, right? So if I focus on here, -3 equals 3 minus x. If I subtract 3 from both sides, I end up with a -6 equals -x. And I divide by -1, and I get 6 equals x. Now, here's the problem with that. If we go all the way back to the top, right, up here, we said that x couldn't equal 6. But when we solve it, we get x equals 6. So what this means is that there is no solution. Okay, we're going to look at one more example. So I've got this on your second page. Okay, so we've got 3y minus 2 over y squared minus 4 plus 4 over y plus 2 equals 1 over y minus 2. Okay, so if we look at the denominator of this, we've got y plus 2 times y minus 2 is what makes up that denominator. And remember, I've already got the y plus 2 here and the y minus 2 here. And so that cannot equal 0, which means that y cannot equal positive 2 or negative 2. Okay? So, now, how am I going to get rid of this? Well, I'm going to take the whole equation and I'm going to multiply it by my common denominator. Okay, so my common denominator here again is that y plus 2 and y minus 2. So if I distribute that through, I get 3y minus 2 equals y plus 2 times y minus 2 all over y plus 2 times y minus 2 plus 4 times y plus 2 times y minus 2 over y plus 2 equals 1 times all this stuff, the y plus 2, I know I'm running out of room here, y minus 2 over y minus 2. Now how does this help us? Well, it allows us to cancel a whole bunch of stuff. Okay, so all of this is going to cancel with all of that. The y plus 2 cancels with this y plus 2, and the y minus 2 cancels with that y minus 2. So what am I left with? Well, I've got 3y minus 2. Let's make this a little bit darker. Equals 4 times y minus 2. Oops, this is not an equal. This is a plus in between here. And then that's going to equal y plus 2. So we distribute. And we combine our like terms. Okay. And if I subtract y, I've got 6y minus 10 equals 2. 6y equals 12, and I get y equals 2. Oh man. So remember, y could not equal 2. So again, this gives us a situation of no solution.